have a new chapter. We have moved to the new chapter because we have done our chapter 1. So let's recall a little bit our chapter 1. Okay, so what we have learned in chapter 1 is you have 1.1, that is all the terminologies, all the term in statistics. So what you need to know is what is parameter, what is statistic, and what is statistics in general. And then you have population, and then what else? You have sample, and you have descriptive statistic, inferential statistic. Alright, so what else we have in 1.1? All the terminologies, right? And also you have the 10 notation that you need to remember for parameter and statistic. Okay, in 1.2 what you learn is the 6 step in problem solving methodology. Okay, so in problem solving methodology you have learned to identify, and then you have learned to classify your data. So your data, you have quantitative and qualitative. Okay, and then you have the sampling technique. Okay, so in 1.3 you have what we call it as review on descriptive statistic. Okay, we have 3 measures here: measure of central tendency, measure of variation, and measure of position. Okay, in measure of central tendency you will have mean, mode, median, and mid-range. In measure of variation you will have range, standard deviation, and variance. In measure of position you have percentiles, deciles, and quartiles. And last, also second last, in 1.4 you have outliers and you have box plot. Okay, last in 1.5 you have what we call it as normal probability plot. Okay, that's all what we have learned in chapter 1. It's about the data. Okay, it's all about the describing the data, collecting the data, sampling technique, and so on. So now we will move to chapter 2. Chapter 2, sampling distributions and confidence intervals. We have moved to another step. We want to make inferential statistic. We want to make analyzation to our data. Okay, now you have data. Now we want to analyze your data, not just describing. We want to analyze. Okay. So what we have here in our chapter 2, these are the expected outcome. So by the end of this chapter, you should be able to find confidence interval for the population mean. You will learn confidence interval 1 mu. And then confidence interval, the difference between two means. And then you will have confidence interval for mu1 minus mu2, and for independent sample, and mu capital D for dependent sample. And then okay, this one is independent, this one is dependent. Able to find confidence interval for proportion, and confidence interval for pi 1 minus pi 2. And lastly, you will have confidence interval for variance and standard deviation. So all these we will learn in this chapter is about confidence interval. What is confidence interval? Selang keyakinan in bahasa. Alright, so don't worry too much. Okay. Next, what are the contents? So in chapter 2 we have 2.1, 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. So don't worry, we'll go one by one. So for this time I will cover this one, 2.1 and 2.2. Estimate, estimation, estimator, and confidence interval for population mean. Once you know how to do confidence interval for population mean, you can do on yourself the rest of the confidence interval. Okay, next. Sorry. 2.1. Estimate, estimation, and estimator. So you have to know what does it mean by estimate. What is estimation? What is estimator? So roughly, estimate is guessing. You just make an estimation. You just guessing, right? Estimation is the process. Estimator is the one that you use to estimate. Okay. So in 2.1, you will learn to define and identify what does it mean by estimate, estimation, and estimator. Estimate, basically we want to guess, estimate. Okay, penganggaran. Right, estimate, estimation, and estimator. So if you look at here, statistic is the estimator for parameter. Means that you have population and then you take a sample. You want to estimate this population using this sample. So that is the basic one, right? I repeat again, we want to estimate population using sample. We want to estimate parameter using statistic. Okay, theta is the parameter, theta cap is the statistic. So theta cap is the estimator of the data. So estimation, entire process. Okay, we have two types of estimation. There is point estimation and interval estimation. So point estimation, we estimate 1 point only. Okay, for the parameter, the estimator for mu is x bar, estimator for sigma square is s square, estimator for pi is p. So how about interval estimation? We estimate using range, selang masa. Right? So these are the properties of good point estimator. It must be unbiased, consistency, efficiency, and sufficient. So before we go more further, let me explain to you, illustration to you, what does it mean by estimate, estimator, and estimation. So I hope you can understand by looking at this explanation.
Now I will explain to you estimate, estimator, and estimation. Okay, let's say I want to estimate the population mean height of all UMP student. Saya nak anggarkan purata ketinggian semua pelajar UMP. So what I have here is I have the total population of all UMP students. So this one is the population, all UMP student denoted by capital N. So what I do is I take a sample, which is my sample is student from FIM. What did I do is I calculate the sample mean height of students from FIM. So the sample mean height denoted by x bar. So I want to estimate the population mean height all UMP student. So I want to estimate this mu. So I will use this x bar to estimate this mu. So this x bar, we call it as estimator. So how about the entire process here? So this entire process here, we call it as estimation. So as stated in the slide just now, there are two types of estimation. The first one is point estimation and the other one is interval estimation. Point estimation, kita anggarkan menggunakan satu titik. For example, I want to estimate mu using x bar. Let's say my x bar is equals to 1.4. So this 1.4 is the estimation of this mu. So this mu is equals to 1.4 at only 1 point. How about interval estimation? When we talk about interval, we will have range of value. Kita akan ada beberapa nilai, which is negative infinity until infinity. Why? Because of we will gather continuous data. Okay, let's say I estimate my mu in between 10.5 until 12.5. 6. So what does it mean? This mu can be any values between 10.6, 10.7 until 12.5. So it can be any value in this interval. So this is interval estimation. From the definition of interval estimation, penganggaran menggunakan selang, we will have what we call it as confidence interval, selang keyakinan. What is confidence interval? Confidence interval is the estimated range of value which contains the value of the parameter. Selang yang mempunyai nilai parameter yang kita estimate. Right. Normally, we will write down confidence interval, open bracket, A is a value, B is a value, and then close bracket, or A less than mu less than B. Okay, in this interval. Number 2, confidence limit, sempadan keyakinan, is the endpoint of a confidence interval. If you write down your confidence interval AB, A will be the lower boundary and B will be the upper boundary. Sempadan atas dan sempadan bawah. So these two we call it as confidence limit. Number 3, interval width. Interval width is equals to the upper boundary minus lower boundary. So width is equals to B minus A. So width can determine how precise or how accurate your estimation. The smaller the width, the interval estimate is more accurate and precise. So we want to be our width is smaller. Number 4, confidence level. Confidence level is the percentage of probability that contain the parameter in the interval A, B. Berapa persen kita anggarkan yang parameter itu berada dalam selang A, B. And normally the confidence level used is 90%, 95% and 99%. And the commonly used is 95%. For example, mu is in between 10.5 and 10.9. So, I said that 95% the mu will be in this interval. Okay, number 5, significant level, denoted by alpha. Significant level is the percentage of probability that do not contain the parameter. It's the opposite of the confidence level. And normally we will use 1%, 5% and 10%. Okay. How to calculate confidence level? So to calculate the confidence level, we will have the formula. Confidence level is equals to the probability 1 minus alpha times 100%. Okay, for example, alpha is 5%, so it will be 0.05. So confidence level 1 minus 0.05 times 100%. We will get 95%. Okay. Another example, given to you confidence level is 90%. What is the significant level? So 1 minus alpha times 1% equals to 90%. So 1 minus alpha equals to 0.9. Alpha equals to 0.1. Okay, this is how we calculate the alpha. Right, the illustration here, we have a normal distribution for continuous data. We have boundary here. Here is your upper boundary. Here is your lower boundary. In the middle here is the 95% percentage that contain the parameter. And how about this one? This one is the error, alpha, that do not contain the parameters. Because of we have two boundary, so alpha divide by 2. Okay. Last, number 6, estimation error. In estimation, there's always been error. Tak semestinya apa yang kita anggarkan itu adalah tepat. So, mesti ada error. So, probability x bar minus error less than mu less than x bar plus error equals to 1 minus alpha. Means that we have to minus error for the lower boundary and we have to plus error for the upper boundary. This one is lower boundary, this one is upper boundary. So, how do we calculate the error? E is the margin of error. Also, margin of error. So, width is equals to B minus A. So, here B is x bar plus E minus A. X bar minus E. Expand the equation, you will get equals to 2E. So, this is what we got. Width is equals to 2 times error, also equals to B minus A. So, you have to remember this formula. Okay, let's get back
Watching the video just now, by hearing all the explanation, so let's go back to the slide. So we have 2.1.3, the confidence interval. So I have explained to you just now, right, what is confidence interval, and this is the confidence interval, confidence limit, and then you have interval width, you have alpha confidence level of significance. So you have confidence level, and then you have alpha level of significance. This one is error that does not contain the values. This one is contain the values. And then you have confidence level. I've explained to you already the confidence level. And then 95% confidence level. So you have this illustration. This one is the part that have the estimate values, and then this one is your error. So we divide by 2 because we have the lower limit and the upper limit, the part that do not contain the estimation value. Alright, this one is the probability. So when we do estimation, we always have error. So lower boundary minus the error, upper boundary plus the error. So you have this one. From this probability, you will get interval width equals to 2E. Okay, so the estimation error also I've explained to you. And then now you have one-sided confidence interval. So just now you have two-sided, where your error you have two sides, lower boundary and upper boundary. So your alpha is divided by 2. This one is your confidence level. So let's say now you have one-sided, means that you only have one side error. If you have one side error, alpha not divided by 2. Alpha stand alone. You have only one side of error. So if it is lower boundary, so theta is minus the error. If it's the upper boundary, it is plus. Okay, so you have to look at the situation or the question. The question asks for one-sided or not. If one-sided, alpha cannot be divided by 2. Alright. Okay, now we go for 2.2, confidence interval for population mean. So done for the explanation what is estimation, estimator, and done for the explanation of the confidence interval, selang keyakinan. Now we want to do confidence interval for population mean. We want to estimate mu using confidence interval. We want to estimate mu using sample mean. Okay, so in 2.2 confidence interval for population mean, we estimate confidence interval for the population mean when population variance standard deviation is known, and estimate the sample size by using the concept of confidence interval. For now on 2.2, you need to have your statistical table. It is very important for you to have that one because it has all the formula. The formula is given in your stat table. You don't have to remember. Okay, it's all given. You just have to know how to use the statistical table. Okay, so confidence interval 1 mean. So confidence interval for 1 mean. So in confidence interval, we have 1 mean. We have 2 mean, mu1 and mu2. For 2 mean, we have divided by 2. Independent cases independent cases mu1 minus mu2, and dependent cases is mu d. So we will look at this one first. Confidence interval for 1 mu. Estimate the mu using confidence interval. Okay, confidence interval for 1 population mean. Confidence interval for 1 population mean. So for example, you have this population and you want to know this mu for this population. Okay, and then we estimate using this sample. Okay, this is the basic concept. Okay, recall back, we talk about a continuous data, so a normal distribution. So normal distribution is symmetric. So this is just derivation, how we get the formula. So lastly, the formula for the confidence interval 1 mean is here. Okay, x bar minus z alpha over 2 sigma over square root n. This part is your A, lower boundary. Okay, less than mu less than x bar plus z alpha over 2 sigma over square root n. Okay, this part is your B. Okay, so how about this one? Z alpha over 2 sigma over square root n. This one is your estimation error. If you recall back, you have mu minus error for the lower boundary, and then you have mu plus error for the upper boundary. So this error actually this formula. So the formula E is z alpha over 2 sigma over square root n. So what is x bar? X bar is sample mean. What is sigma? Sigma is sample standard deviation. And what is n? N is sample size. So by right, you have know all the symbols here. You have to remember all the symbols. When we talk about sigma, what is sigma? What is n? What is x bar? Okay, so we will use this formula to find the confidence interval for 1 population mean. So this one is the estimation error that I talked just now. You have the lower boundary and the upper boundary. Alright, the estimation error. So just now I said this one is the formula. Where we get this formula? From this one, mu minus error less than mu plus error. So the error here is this one, the formula, z alpha over 2 sigma over square root n. So if you look at here, if we increase the sample size, what will happen to the error? Error will be decreased. Okay, if you increase the standard deviation or the variance, error will be increased. If you increase the significant level, error will be decreased. So you have to know this one. If sample size increase, error will be decreased. If standard deviation increase, error will be increased. If alpha is increased, error will be decreased. We talk about the error. Why? Because estimation always have error. Tak semua kita buat anggaran itu tepat. Right, so now come to the formula. So please look at your formula in your stat table. The formula is in page 5. Okay, so the formula is in page 5. So what you need to do is, first you have to read the question very careful, and then you have to determine, is there any sigma square given? What is sigma square? Population variance. If sigma square is given, you have to use this formula, the first formula. Okay, this one is your lower boundary, this one is your upper boundary. If in the question they doesn't state sigma square, they do not give to you the sigma square or the standard deviation population sigma, so you cannot use the first formula. You have to consider this one. This one is sample size. If your sample size greater than and equals to 30, use the second formula, Z test. If your sample size less than 30, use the third formula, you will have the T. Okay, so different here, sample size greater than 30, use Z. If sample size less than 30, you will use T, alpha over 2 and nu, where the nu is n minus 1. Okay, this one is Z table, this one is T table. So be careful in choosing your formula. Okay, let's try example